So we're going to start the session 1, Develop a Circular Economy for Climate. So this session is shared by Bernard Kurek, Research Director of the UMR INRAE from the University that's called Fractionation of Agro-Resources and Environment, and Romain Debref, Associate Professor at the Economics and Management Laboratory of France. So this session will be until 5 o'clock, and I leave the chairman continue the session.
Ladies and gentlemen, thank you very much for being here today for this scientific session number 1 entitled Develop a Circular Economy for Climate. We'll have the pleasure to welcome Laurie Hamelin, professor and member, leader of the chair of Sustainable Transition towards the Low Fossil Carbon Use from the INRAE in Toulouse. And then we will welcome also Tanguy Fardet, who is a research officer of the OCAPI program au laboratoire Eau, Environnement and Système Urbain at the École des Ponts Paris Tech. And first of all, we will introduce this session with Bernard and I will start. So, as we know, since the Industrial Revolution, our recent society have enjoyed a rapid development without precedent in the history of humanity. So this surge is due to our ability to have innovation, thanks to mineral resources such as coal, oil, and even uranium, which have directly introduced us to a thermo-industrial society. The 70s, however, which is a specific period, which question our development models and growth models. We can observe the publication of the Meadows report entitled The Limit to Growth and the works of the economist Nicolas Georgescu-Roegen, who wrote about degrowth, the concept of degrowth, and all of this kind of work and publication is a good evidence of that our society must be modified. Since then, the challenges that have been enlightened for the past 50 years are far from it has been resolved, and the economic, social, and environmental crisis that we are experiencing today invite us all to change our way of thinking. It's our responsibility as scientists. The latest IPCC report published a few weeks ago confirmed this statement. If you were to the prospective work that it has been done, we can see that we have reached a turning point, whatever the scenario. The Earth will be warmer for us and for our children and grandchildren. That is now a certainty. Bernard, it's your turn.
So we'll make it in 2 voices. So I will try to explain just the main points that are coming out of the IPCC report. And what is really evident is that we have many technical solutions to solve a part of the problem of global warming and to try to mitigate a lot of parameters during the coming years. And what is important is to make the relationship between the technology and the cost needed to reach a target. And what is quite convergent in many reports, not only this report, but also national reports and other regional reports, is that we have to focus on energy with solar and wind solution, some other technologies producing energy like bioelectricity. What is also important is to have carbon sequestration, new techniques that capture carbon, and practices that can just sequester carbon by natural ways, such in agriculture, for instance. What is also very convergent is our building, housing, and how we live in urban areas, and how this can be impact. This can be a good way to mitigate to some extent the carbon emission and so on. The transport is very heavy in the global account. So biofuel is also a solution. And you see other solution in industrial waste like recycling is also installed. Just to say that there is many possibilities. These possibilities are written in several reports and all are convergent. So this is a good target that science and scientific people also has to take into account in their research. So, then, pas trop vite, là. Okay, maybe just, we have to go back. Okay. Just as an example of reports, so one was coming out of the European community written by Uwe Fritsch and colleagues, making scenarios, and in these scenarios it is important to cope that we need something to be incorporated that is a social organization. Technology is good, no problem, we need such thing, but without the environment of social and economic system, it is a nonsense. On several scenarios, like this one in Europe, states a few scenarios where we just wait and we do what is not avoidable, so just we try to mitigate something, but not with a good, without any conviction, I would say. And the opposite is ready to make, to change many parameters of social being and behavior, consumer, producer, industrial, etc. It is really a common way to proceed. And this is probably the most transforming, but it is in all scenarios, it is the most efficient to mitigate what has been shown before, so the heat and gas greenhouse effect of our activities. Also, very recently, ADEME, the national agency, has published also scenarios and perspective of this. And even if it's not exactly the same approach, the conclusion that is written are very similar. So on, it is buckling again with all the building, energy, food, agriculture. All this target has to be synced together to proceed in a good way, I would say, in a good trajectory. So, just also to feel it's not very new. This is can be say, okay, it's not new, but know what are we doing. So just to make that in 72, there is the first really conference stating that something has to be done in industry and global in the social organization of working on goods production and also how society can evolve. Then there is a Brundtland report that is the first description, one of the first description where sustainability has to cope with all these three spheres of activity. And my personal opinion, you can, if you don't want to agree, it's up to you, no problem. The way is new way to recycle. We say that there is this to cope, but you know that there is many products that are just outside our planet, and this is a question that we have to address also. So this Tesla car is in the space, and in University of Toronto, a scientist has calculated that it will take 10 million years to come back to Earth, probably. And also, this picture is very interesting also because it's for National Agency of Space in USA, and this is all a schematic representation on all the pieces, more than 1 meter, that is just going out around our world, satellites, onto garbage of satellites, etc. This means that our problem is obviously what is going on our planet, but we have to cope also with these new, I think, possibilities and also constraints in the next decades. Then I will go back. Yeah.
Yes, back. So the three spheres presented previously by Bernard can only work if you are able to link them together and consider them like subsystems. That is why an economist, René Passet, who wrote a book in 1979, tried to link this sphere together. And it is very interesting because it uses a systemic approach. And the point is that the biosphere influences our society and our institution, and our institution build market laws, for instance. And sometimes the market laws take over the society and the society take over the biosphere, and sometimes the pressure from the biosphere come back and get the pressure on the society. For instance, the climate change. The market influence our practices, how you consume, how you produce, and it influences the climate change. And then the climate change come back and invite us to modify our market laws, not our practices, and so on. So these three spheres are in permanent interaction, which implies that the economic subsystem can put the pressure on the society, and then the biosphere can put the pressure on the economic and house institution, economic sphere. But at the same time, we have interaction. So it means that our society are changing all over the time, like mutations, for the better or worse. And then, okay, I show you, it's now necessary to reconsider our socio-economic system are interacting with the biological world to find a more peaceful relationship. We will call this way of thinking the ecological bioeconomy, used to develop this concept in the University of Reims and the Laboratoire Regard. This first scientist who focused on this issue and this topic is studying the relationship between human and social science. We have some authors, René Passet, I showed you previously, is a French economist, specialist in complex systems, and he proposed the introduction of the normative management of our society under constraint. Nicolas Georgescu-Roegen is a specialist of thermodynamics, economics of production and innovation. He's a Romanian at the base, he lived in the United States, and he proposed a minimal bioeconomic program. And finally, Ignacy Sachs, a specialist in the country of the South country, and he proposed some eco-development strategies which invite us to rethink the relationship between the political sphere, socioeconomic sphere, environmental and industrial sphere as well. So what these authors have in common together? They call for systemic challenge, systemic studies, for understanding the transformation of our society with new kind of methodology and also transdisciplinarity together. So I continue, you know, Pink Floyd, today the ecological bioeconomy is not the only one. And this kind of bioeconomy is joined by other forms of bioeconomy with a very different relationship to nature. Here we find the bioeconomy of biotechnologies, which consists of considering living organisms as an assembly of DNA that can be used to create microfactories that can be optimized to meet, to correspond to our needs without more energy. Here, the international patents competition and the selection by the market in the rules. So the markets will give the law. The other concept is a bioeconomy of biorefineries, which is a result of an hybrid approach between the two first conceptions of bioeconomy. And in this case, the relationship with nature is reduced to a collection of renewable carbon molecules that can be converted thanks to biorefineries. In the end, there are not only one bioeconomy, but bioeconomies. So we have a diversity of practices, diversity of point of view, and all depends of, it have a lot of consequence of the process of innovation and how we want modifying our society. It's true.
Then you see that during all these years, many concepts has been produced because society is obviously changing in all cases. And for all this ideal trajectory to go to the future, then many different approaches have been done. So it's the bioeconomy. One important thing is not obviously sustainable, and so there is a need to manage and to have some indicators and to measure something. And even if measurement can be done from an engineering point of view, we have not to forget that some parameters cannot be measured simply. And this particularly the change in society, how to proceed to get a new idea in the common thinking, and so this can change the people, the behavior, etc. All this stuff can be measured to some extent, but none can not all can be measured. And this is important because if we just focus on indicators, it's one part of the solution. If we go also to other human science disciplinary fields, we see that there is another way to measure something, and we have to integrate all this together to have finally several solutions that could be applied in several territories and in specific countries or regional part of countries to have together social benefits. The first one, this we probably is one very big driver of this, the economical benefits and the environmental benefits together. What is important is that we have to really to cope with all these three together and measure, be able to measure something, and also be able to measure what is non-measurable for the moment, but it is data that we have to cope with. Then the next one, yes, for you.
Thank you. Therefore, beyond the technological promises and the discovery of the hope that we can find the winning technology, we observe that there are diversity of conception of bioeconomy, both complementary and also opposing, but the diversity is also the peculiarities of a complex system. You have also the diversity of scientific practices and methods. So clearly, the technologies and their development are only the tip of the iceberg. Their implementation cannot be possible without considering the diversity of some variables, of elements, key elements for social science and for the colleagues from technological and science and science of nature science. For instance, all depends of the diversity of the origin of the resource. For instance, if you are studying a biomass from an island, on an island, or from in the north, in the south, equatorial area, it depends also on the diversity of location, the relationship to the time. Do we prefer the long term, the very short-term approach? It will influence the process of innovation process. It depends also on the diversity of the population, the number from a demographic point of view. High level of people, low level, it depends. It depends also on the culture and the diversity of the socio-economic system, the history, the rules, institution, the exchange system, the market system, markets law, the social protection. And it depends also on the labor market. So it's the technological hope, the technology is not enough. The technology is included, embedded in this complexity that we we have to study. Okay, so
we'll move now to what we are doing in Champagne-Ardenne. Yeah, it was quite general. I know that there is some redundancies with other presentations that you could have here on what you know, but it was for us important to replace this general context. So, and the main question is, what is university research when we speak from a responsible bioeconomy according to all this stuff presented just before? So, the main things is that there is several trajectories from innovations that can be found in the level of the laboratory and progressively going on with some solution being more and more mature, and with some the importance can change during the time because it is beginning to be a priority of research, and priority of technical solution, and priority of general organization of society. And then you go forward to a regime which is stabilized and can go with a good trajectory toward a sustainable bioeconomy, and something that is good for environment, society, and economics. Then we will give some example of this, what has been done finally in Reims University, because we are in Reims, and so on. So we'll present 4 examples very shortly with I would say it's a hotspot. It will be very simplified, but just to see that we can discuss with a biochemist, I have, and Romain with an economist and other people here, and try to work together and build the program together, and with the thinking that one day it will go into application or will serve a general discussion with the people of the city, of the regional part, and even you can go even national part, as for hemp, for instance, for expertise and so on. Okay, so I will leave you. Okay, okay, so at the different level, first the technical and scientific level. So as I told you, it is the basis. So we make a theoretical law 0 to 4 on trying concept on new ideas. But what are we doing with this? If we look on what is an argument that was given for green chemistry a long time ago, yes, but still there is a winning process that will offer the solution. So it was the idea of one unique solution. So all the research will test many possibilities. And among these possibilities, you will have a main winner who will come back. But there is so many different trajectories that it's difficult to cope and manage this. You have a diversity of biomass. Biomass is so diverse that you cannot just commodify the biomass to have just one solution. And so what is important, we are a community. It's a strong involvement in time, in thinking and so on. So there is some lobbying, also scientific lobbying, that make one possibility coming a little bit more further than the other one. So this is something that we have to cope if we want to have innovation approaches. And then after, it depends also on the year, because from 2008 to now, many project has changed, and the nature of the project has changed with more and more interdisciplinary in order to combine all this stuff here. And in this period here, so in Reims, we have classified according to what we call a productive heritage, so what we can do, what has to be done, and finally what is coming out, with several pathways to use the biomass, classified in a very harsh deconstruction of biomass, to something you keep the structure of the plant, you use them, and you try to have a product that is good in insertion in bioeconomy and in a sustainable system. The other one is agricultural side, and it's yours.
Yes, it's my turn. Thank you. Okay, so we have an example from the technical and scientific sphere, and now I'm going to show you what is happening on the agricultural scale, the biomass producers. So where are we? We are in this area, the agriculture in the level at socio-technical regime. Okay, so we go on the other level. So today, we often get the argument that life sciences and engineering are both theoretically and in practice able to convert biomass in various ways to feed the needs of consumers and users, as shown Bernard. It seems that this argument is more complex than it will occur, and it depends on the access of the resources. Indeed, being able to produce agricultural biomass is a major issue. This is the case for sugar beet production, which for many decades have been used to operating with the use of neonicotinoids while evolving in a favorable economic context. However, this prohibition of this chemical and the global agricultural crisis are challenging the viability of this historically based production model. And these institutional and economic changes are indeed impacting on agricultural productivity for farmers and biorefineries based on sugar beet, for instance. And so it's raised some challenges for the production of bioethanol. So the key challenge is to know, how these actors who are confronted to these uncertainties how do they find solution? Are they willing to innovate to change radically? So are they innovating to find alternative, or do they prefer innovate to resist? Okay, we can innovate to resist the change, and you can innovate to provide some alternatives. So this has some implication in the scientific sphere, because sometimes we need some help from policymakers, for instance, for subvention, fundings for research projects. So sometimes the policymakers are very important, and they kind influence the process of innovation for a research project, for instance, the PhD thesis, the subvention for postdoctoral fellows, and etc., etc. Okay, Bernard, it's your turn.
Then what we would like to emphasize also is that obviously sugar beet can be correlated with the first presentation of all the different kind of biomass deconstruction. But also you can consider that biomass, if you have a good biomass in an agricultural system like hemp, and locally here we are the first European producer of industrial hemp in Europe. And then it can be criticized because if hemp can be considered as a bioeconomical system, giving value, agroecological value, social value, and employment, and also finally money for all the people working on hemp for industrial application, so textile, automotive industry, etc. There is a criticism today because there is another part of the plant who is currently investigated at the national or even European level, is controversial because it's a CBD that is used for recreational purposes and wellness, and also the THC, which is for a long time it has demonstrated therapeutical usage, and this is a main problem. So if you consider this part, this is very well installed in the system and can be considered as a sustainable bioeconomical subsystem. This part is giving a new way to see all the plant, and we have to cope with this, to insert this in a complex and full agronomical system where hemp is produced, then you have other culture in the field, and then it will contribute to a sustainable system. Just the other thing is there is then it's asking the questions like, can we change sugar beet is industrial production, very huge surface, etc., very installed system. Can we use our land differently? And the question is yes, and it's one of the main points that is stated in the IPCC report, ADEME report, European report, etc., to introduce more agroecological system in our landscape. And this will just change the landscape, will change how you use the surface to produce forest, biomass, etc., and how you will make this. But one problem who really is showing that we need to work together with economical and scientific system is what is the value of carob? I don't know the carob, carob, which is a culture auxiliary, and you can save some pesticide and some product if you can manage a population with ecological system, full ecological system. And this is what we are currently working together with Zoras and so on, and for Dominique and so on, to try to understand how the value can be done with this. And this will be explained better by an economist.
Yes, so we are talking about economic value. So there is also a big challenge for farmers in terms of economic evaluation. So as Bernard has shown, the transformation of our agricultural practices is very important. But how can farmers reconsider their methods if the monetary dimension is still the only way to access the economic viability of activities? So in some project that we developed in collaboration together with the colleagues in the amphitheatre, we observed that the accounting of agricultural activities which are managed here as private enterprise, or because the farmers manage it like private activities, does not consider the complexity of the environment. So the agriculture is, the evolution, the mutation of the agriculture is only influenced by monetary decision imposed by the bank, financial stuff, etc., etc. So, however, does it work? Yes. Apologize. However, the environment offers other forms of non-monetary wealth that invite us to rethink our relationship to space-time. So therefore, new economic and accounting evaluation tools are required in order to link, in a better way, the economic sphere, the institutional sphere, and the biosphere, as we showed you previously. So let's let's follow this argumentation because we would like to show you the consequence on the agricultural model. So beside environmental accounting, the consequences of agricultural models and farmer strategies must be also studied. The biomass production requires the farmers to make trade-off and to ask themselves two key questions. On the one hand, the first pillar is how produces the biomass and who transforms it, who processes it. So who produce, who transform. Two options. I'm a farmer, I can produce the biomass by myself and produce it on the farm. Or I can produce the biomass by myself and I sell it for a transformator. It is the first pillar. The second one, on the other, why do we produce this biomass? For what kind of needs? First, I can produce the biomass to recover or to get renewable carbon for substitution with petroleum, for instance. And I can also produce the biomass to preserve the complexity, its complexity, because there are a lot of interesting functionalities. Only with these two kind of pillars, we identify in the research project, in the interdisciplinary projects entitled BioECA, Bioeconomy en Champagne-Ardenne, we identify 4 agricultural models which emerge thanks to the bioeconomy or because of the bioeconomy. So we are 4 models. The first one is the biomass farming, based on the production of biomass to produce bio-based carbon produced by industrial infrastructure. For instance, the biorefinery of Bazancourt-Pomacle. It is based on the agriculture produce the biomass for agro-industrial seeds in order to, on the left, obtain the renewable carbon. Okay? So we have the biomass farming. If I am a farmer and I want to produce biomass in order to sell it for the interesting molecules, I become using the molecule farming. It is based on a high-value added plant production for molecules of interest obtained by industrial infrastructure, for instance, alpha-alpha or hemp or sainfoin, for instance, for the protein or for fibers. Or if I'm a farmer, if I want to produce it by myself, I can choose to produce by myself in order to produce renewable carbon or something like that, like methane. We identify the model entitled the energy farming, the production of purchase of biomass for energy recovery for the biogas, electricity heat. It is called digestion, etc. Methanization. And we have also the last one, the farmers decided to produce by themselves and innovate in function of the environment, their own environment. The landscape, for instance, or the biodiversity, it's the basement of the process of innovation for sustainable bioeconomy. We are 4 kind of model, but today we are go ahead. We need more details, and we observe some hybridation. Sometimes we have some profiles. We have farmers that call for agroecologist practices, but at the same time, they are using methanization, digester, to increase increase the efficiency of their model. And we can also mix the process with the molecule farming and agroecologist farming, for instance, to produce the molecule of CBD. In France, a lot of farmers using biological agriculture, they developed a lot of innovative projects to create and to produce the CBD. Okay, so it's very interesting to show the diversity of agricultural model, and all of this can be developed on the same territory, and sometimes by the same farmer. That's why it's very complex. So let's see what is happening on the agricultural industrial way. It's mine. Okay. So let's start. What is happening on an industrial scale? The transformers, the companies, the manufacturers. So we are here. For instance, the technology. We have manufacturers who have a lot of capital, and they are able to produce, for instance, a car, for instance, a bio-based product, plastic, bottles, and so on and so on. So, for instance, I think it's your turn. Yes, it's your.
So the examples that we would like to show you is the way to approach what is the sustainable or what is going on into circular economy, which is also a part of the system. So the argument says that scientists are writing bio-based, it's good. If the products are better, then no problem, it will be diffused on use. It's not so simple because on the other side, in parallel, in fact, all the common currently going on product have also their own research strategies on research trajectories where they are also thinking on circularity, on recovery of material, on getting rid of some loss of carbon during the process. And this is shown here with the automotive industry, where here you have a panel for a car made of plant-based material by a tier 1 supplier for automotive industry in collaboration with Reims University. And so this is a commercial piece, including in car. And the main argument was it was lighter, it could be recycled, and the carbon footprint is lower. But if you take a normal one, then say, okay, I will just take this, I will grind it, I will separate, make some technology, and then recover again the material and put it again in the system. And the discussion or controversy that is together is what is better. In fact, it's not better or not. We need finally two approaches because there is advantages here, and inconvenience here, and here also. And so we cannot oppose, and we have not to oppose the system. This was not the case a few years ago, where people say bioeconomy is good, bio-based is good, and chemistry, petrol is not good. No, we are ready to work together because each solution can be important in this case. So this is really a concrete example of research collaboration thinking and then going on into new questions involving our partner here.
Yes, and it is a typical innovation strategy for companies. Indeed, manufacturers also have a role to take in the innovation process. We might imagine that firms contributing to climate change and are not, we argue that some people argue that the company contributing to climate change cannot be a leader for triggering a sustainable transition. But from a strategic point of view, this argument is not correct, as shown Bernard, because the reality is that companies with a high capacity of investment develops some option strategies by keeping their core business, okay, while specializing in issues that did not concern them initially. For example, a company which is specialized in the production of plastics can first say, okay, I keep the petroleum-based option. It's the core of my activity, so I have the monopoly maybe in this area. But as company, I have some option. I spend some money to develop some bio-based option, and sometimes I can also hybrid the both together. So I have 3 markets instead of 1. So from an economic point of view, it's a great strategy. We keep the core, but you have the option. And if you create some patents, you can take over some interesting markets. I take my favorite example, for people who know me, the resilient flooring, for instance. We used to, we have this famous product. Basically, this product is based on PVC and recycled PVC, okay? But the leader, the market, developed some alternative strategy based on the mix between PVC, recycled PVC, and bio-based plastic, okay? But the functionality are exactly the same. And there is also a very old product called the linoleum. This old product has been created during the 19th century, and it is based on linseed oil, jute, rosin, etc., etc. Okay, and the recipe don't change. It has been created in 19th century. The recipe is the same. So we have retro innovation that are coming back and show how the bioeconomy is evolving. Okay. Okay. It's my turn as well. So let's see what is happening on the usage scale, the consumers, because the consumers is very interesting and very important, because we are talking about the farmers, the manufacturers, and we need to talk about the consumers. So the consumers is everywhere, on the top of the system, in the landscape, in the socio-technical regimes, and also in the niche innovation. So let's see what is happening. Some articles are very interesting locally, from the local media. We observe that the policymakers... Oh, excuse me, yes. We observe that the policymakers from the Grand East region encourage the use of biofuel produced that are produced locally. So we observe that €2 million have been deployed since 2019 by the Grand East region for the benefits of 5,000 motorists. So we observe, if you observe the figures, that the super ethanol is disseminating on the territory thanks to the farmers also and the biorefinery, and because 97% of beneficiaries come from this area. Okay, so it could be very interesting because we are able to produce local fuels for local citizens. However, it has a consequence from a macroeconomic scale. This, for instance, the paradox is entitled the rebound effect. So imagine you look on the left, the price of ethanol is about 60 cents of euro, and the same, the gasol, it's around 150 cents, something like that. So we imagine, we show that the price of bioethanol is cheaper than the gasol from the petroleum, from mineral resources, okay? However, the bioethanol is very interesting. We observe that policymakers encourage the adaptation of engines and motors in order to be more efficient. For the consumers, we observe a lower cost, so it's cheaper to use this kind of new fuels. It could increase purchasing power, so with the same budget, you can buy more things, or you can drive more, because the bioethanol is cheaper than mineral resources. So if it is an opportunity for the consumer, we observe an increase of market demand, and the consumers want more fuels for bioethanol, so it could increase the pressure on crop, and the policymaker give subvention to accelerate the process. So this paradox is entitled the Jevons paradox, rebound effect, and it has been identified during the 19th century. Okay. In conclusion.
Yeah, as a conclusion, so first, we are just on time, just 1 minute. We apologize, but I think it's also a good example because it's difficult to make a two-disciplinary presentation together. If Romain has done his own presentation alone, on me alone, it would not have been the same results. And this is a good example of what is collaboration and transdisciplinarity also. It takes a long time, and you take time to explain a little bit more. So the working method is that we can access together with several different disciplines and communities together, and try to understand the complexity of all this, not to be too reductive, even if it is a little bit simplified here, and not too not too specialized. We have access also to a lot of expertise on public policies and decisions that you can analyze together to go to progress. The fourth point is the teaching, which is really important because we know that the people that we are teaching today in university or engineering school, etc., has to cope with all this complexity. And you have seen that there are a huge variety of diversity of possibilities to learn something, to search something, and to find something. And also, the working method is to involve all the stakeholders in the field. So we are just working in our laboratory. We are working with industrial, with public, so cities and countries and so on. And so we can really have a good creating links together in order to progress in our interdisciplinary research. So I'll use the last word is for you.
Ready? Okay. In conclusion, we would like to show you how our thinking evolved. It is thanks to a lot of projects together that started during the millennium, thanks to Martino Niedu. So thanks to him, we developed a lot of projects. It starts in the laboratory, regards laboratory, and then we have some projects, LINR, double green chemistry. We worked with Bernard, Estelle, and then we have another project entitled bioeconomy in Champagne-Ardenne, led by Martino and then from Dominique Vivien. And then we observe for the future a dissemination on alternative projects that you see that today we are able to work in interdisciplinarity to analyze various topics and complex topics dealing with the bioeconomy. So thank you very much for your kind attention.